Hello everybody, this is Mr. Bowman. So today we're going to be looking at the ALEX topic, solving a word problem using a system of linear equations of the form Ax plus by equals c, or standard form. Okay. Alright, so in this one we have a fruit company that delivers fruit in two types of boxes, large and small. Delivery of 3 large boxes and 5 small boxes, has a total weight of 77 kilograms. And a delivery of 6 large boxes and 2 small boxes has a total weight of 104 kilograms. How much does each type of box weigh? So we're going to set up an equation for each type of delivery. So sorry, not type of delivery, but the first delivery and the second delivery. So I want my variables to represent the part I'm actually trying to solve for, which is how much does each type of box weigh. So we'll make x the weight of a small box, and y be the weight of a large box. Okay. So setting this up, 3 large boxes and 5 small boxes would be 3y, because that's a large box. 5 small boxes would be 5x. It has a total weight of 77 kilograms. And for the second one, a delivery of 6 large boxes, so 6y, 2 small boxes would be plus 2x equals 104. Okay. Now, you may have set this up differently, where x was the large boxes and y was the small boxes, in which case your variables would change here and be 3x plus 5y equals 77, and same down here. That's fine, and that will work just well, which is why I'm making the note here. Either way, we should end up with the same 2 numbers. They might be reversed for x and y, but it'll still be the same weight for a small box and the same weight for a large box if you did it correctly. So if you have a slightly different setup, that's okay. All right, so now to solve this thing, I think I'm going to do an elimination, because I have a 3y and a 6y, so I can multiply this entire top equation by -2 to end up with a -6y to cancel out my positive 6y. So remember, we want to eliminate one of the variables, which means we need to make sure their coefficients add up to 0. So if I switch this one, I end up with -6y, because I'm distributing, and I'm going to distribute to all 3 things. So minus 10x equals negative 154, unless I am much mistaken. And then this one, I don't need to do anything to, so I will go ahead and leave that alone. Okay. All right, so now I'm going to go ahead and eliminate them, which means I'm going to add my equations together so that these two can add up to 0. So this is 0y, which is gone, and then over here I end up with -8x, and then over here I have -50. Okay, so now I just need to divide by -8, and I end up with 25 over 4 when I reduce that, or if you prefer decimals, which a lot of people do in these situations, 6.25. Okay, so now I can take that and plug that back into one of my equations. I think I'm going to go ahead and use the second one just because I didn't have any manipulation there, so that might make it a little bit easier on me visually. But mathematically it shouldn't make any difference. So I'm plugging that in for x, so I have 6y plus 2 times my x value of 6.25 equals 104. So I'll go ahead and multiply these together, which should end up with 12.5. All right. So then I need to subtract that off, right? So minus 12.5 minus 12.5, I end up with 6y. And then after I do my subtraction, 91.5. So divide by 6, and see what this turns into. So that turns out to 61 over 4 if you want the fraction, or 15.25, so 15 and a quarter if we're looking at the decimal. So then to give my final answer, I'm going to come over here and interpret them. So a small box is my x, so it would be 6.25 kilograms. Make sure we're careful with our units here. Don't write pounds or something. And then the large box is going to be our y, which is 15.25 kilograms. And it's always a good idea when you do a system of equations to make sure it makes sense. So to make sure we didn't flip our variables around. So does it make sense for a small box to weigh 6.25 and a large box to weigh 15.25? Yeah, that's fine. So where we want to make sure we don't make a mistake is if the small box weighed more than the large box, that would be a problem. So just make sure we have a logical answer there.